This video is for section 1.8. Today we are talking all about the inverse functions. You'll notice that we'll touch on two different targets for this chapter, target 11 and target 12. Let's go ahead and get started. The first thing is just to talk about the definition of inverses. Now, if two things are inverses, that means that f of g of x and g of f of x will result in the same answer, x. Meaning basically that these two functions undo each other. If you put x into one and the answer to the other, you'll get back what you started. So if f of g of x equals x and g of f of x equals x, then f of x and g of x are functions. Okay, so for our first example, I'm going to give you two functions here, f of x and g of x, and we are going to show that they're inverses. Now remember, in order to show that, the first thing we're going to find is f of g of x, and then we'll also find g of f of x, and then we want to make sure that we get back out x in both these cases. Let's start with f of g of x. So we're going to take g of x and put it into the function of f. So we're going to have 3 times x minus 2 over 3 plus 2. Now, and the nice thing here is that the 3 timesing by 3 and dividing by 3 cancel out, so we get x minus 2 plus 2, and that just equals x. Now, in this case, it works. F of g of x resulted in x. But remember, we're not finished here. We need to check it both ways. We want to make sure that that g of f of x also results in an answer of x. And so now if we do that, and we go the other way, we are going to take 3x plus 2 and put it into the g function. So we'll get 3x plus 2 minus 2 all over 3. That simplifies to 3x over 3, which is just x. And once again, g of f of x equals x, and so does f of g of x. So now we have shown that these two functions are inverses. If you look just at this graphic for a minute, you can see that really what's happening the first time is that we're multiplying by 3 and then adding 2 to get to the 3x plus 2. If I go backwards, so here we're multiplying by 3 and adding 2. Over here, we're subtracting 2 and then dividing by 3. We're doing the opposite. We're working backwards. And so you can see they both undo each other, and in the end, we result in the same answer. That's what it means to be inverses. They basically undo each other. Now that we know how to show if two functions are inverses, I want to start by giving you a function and you just finding its inverse. Now, in order to find the inverse of a function, the first thing you'll do is interchange the x and the y. So switch the x and y. The second thing you'll do is solve for y. That answer will be your inverse function. Now, one thing to remember, f of x is the same thing as y. So here, just remember those f of x's mean the same thing as y's. So let's work out two examples. Here's our first function, f of x equals 7x minus 5, and we want to find its inverse. Remember, the first step is to interchange the x and the y. So we'll say x equals 7y minus 5. We just switched the x and the y around. Again, don't get confused, f of x is the same thing as y. Remember, the second step now is to solve for y, so we'll add 5 to both sides. X plus 5 is 7y, and we'll divide by 7. Now that answer is our inverse function. Just a little bit of notation here. Remember that the fancy way to write inverses is f to the negative 1 of x. That means it's inverse. And we've got x plus 5 over 7. That's the inverse function for 7x minus 5. Why don't you pause your video and try the next one? hopefully you came up with the cubed root of x minus 1. Now be careful for two things. The first is to remember to subtract 1 before you take your cubed root. And so the whole thing x minus 1 is under that cubed root. So just to review, in order to find an inverse, if I give you a function, you are going to want to switch the x and the y value and then solve for y. The answer will be the inverse. Alright, now let's take a look at some graphs, and we're going to talk about inverses in terms of graphs in the next two objectives. The first thing I want to take a look at is the horizontal line test. Now, if you remember when we talked about the vertical line test was to determine if the graph was a function. Now, the horizontal line test is going to be used to determine if a function has an inverse. So now let's take a look for a minute. These following graphs are functions. We want to know, do they have inverses? So these are not the graphs of the inverses. These are the graphs of the original functions. We know these are all functions. All these four graphs pass the vertical line test. What I want to know is their inverse going to also be a function? So we'll just switch the x and the y around, just like we talked about in finding them from the equations. We flip the x and the y around. If we're going to switch the x and the y around, really we're now going to take a look at the horizontal line as opposed to the vertical line. So because this first graph A passes the horizontal line test, it only crosses the horizontal line once, we can say that the inverse is a function. The inverse is a function. Now remember, the starting graph is f of x, the function, not the inverse. The second one does not pass the vertical line test, the horizontal line test, I'm sorry. So that means that this graph's inverse is not a function. The inverse is not a function. Same thing for the next one. The inverse of this is not a function. The last one passes, see this one crosses 3 times. The last one only crosses once wherever I draw it. So that means, yes, the inverse is a function. Now, if I want to take these pictures of the original function and graph the inverses, that leads us into the final objective for today. How do I take a picture and how do I graph its inverse? Now, all three of these shown here are all graphs of equations and their inverses. The way that we'll graph the inverse is you have two options. You'll notice by looking at all these pictures that they're all symmetric over this y equals x line. So if you'd like to use symmetry, your first choice is to flip the graph over y equals x. Okay. Now, if you don't like that, the other option you can do is just switch the x and y values and plot the points. It's doing the same thing. So if you switch your x's and y's and plot the points, you'll also get the graph of the inverse. So let's try a few. Here's the first one. You can see it's a square root graph, and I want to graph its inverse. So what I like to do is I like to switch the x and y values. So I'm going to look at this first point here, and I can see that that point is 3, 0. So if I'm going to graph the inverse, instead I'm going to just switch those around and graph 0, 3. And I'm going to do that for each of the nice main points. So here's the next one. It looks like that point is at 4, 0, so we'll go to 4, 1, so we'll go to 1, 4. And I'm just going to pick one more maybe out here, and it looks like it's at 5, 2, so we'll go to 2. Is that 5? 1, 2, 3, 4, 5, 6, 7, 2, so we'll go to 2, 7. And now we can get the graph of our inverse. So if the original graph was f of x, the new one is the inverse. Why don't you pause your video and try this x cubed graph and see how you do, and then we'll check your answer. Now when you graphed this one, hopefully you noticed that those first 3 points in the middle, they all were actually at the same spot. So the changes came out here on the outsides when that graph got flipped over that y equals x line. This ends our notes for today. I'm going to give you 2 questions for your Google form. Here's the first one. Find the equation for the inverse if f of x equals 4x minus 5 all over 2. And secondly, your multiple choice question, I want you to find the equation for the inverse if f of x is x minus 3 cubed. Don't forget to put those answers into your Google form, and then we will see you in class tomorrow.